Hey everyone, and welcome to the second lecture in the series of lectures on the topic of inequalities, linear inequalities. And in the previous lecture, we introduced what a linear equation is, and what does equality mean, and what does inequality mean. We looked at different symbols that are used in inequality in equations that are unequal. So after that, we solved a couple of very easy examples just to get you the feel of what linear inequality in one variable is. In this lecture, we would talk about the properties of inequalities. Basically, we'll be talking about the properties of inequality equations, linear inequality equations in one variable. So if you see on the slide, we would be using this convention in which a, b, and c would be real numbers, and this is what we're doing right now. We're not going to go into complex decimal numbers or irrational numbers for now. So of course, you might ask some questions, but let's just focus for this. Let's just focus on this right now, on the real numbers. And another thing that I want you to note is that the properties of inequalities will still hold true using the relation symbol greater than and equal to and less than and equal to. Now don't get confused by the point that although it is unequal, it shows greater than or less than, but it also says equal. The thing is it's all about the definition of equality and inequality. If there's a symbol of equals to, that is the two dashes, the parallel dashes, only then would we call an equation as equal, as an non-inequality equation. Other than that, whatever symbol that we're going to use, it's going to be a linear inequality equation. Is going to be a linear inequality, either it's greater than or equal to or less than or equal to. The only thing is that the only and if and only if you have an equals to symbol, would that not be an inequality. Otherwise it would always be an inequality. So don't get confused by the point that you have equal to, either greater than or less than symbol over here. So let's start with the properties. Let's start with the first basic property, that is the addition property. So what an addition property basically states is that if you have an inequality in which if you have 2 points, that is a is less than b, and if you add anything on both the sides of the inequality, that is if let's just say it's 2 over here, a is 2 over here and b is 3, so this is going to be true. That means 3 is greater than 2. Now if you add anything on either side, this inequality will still hold. That is, the one, if you add over here like we have done in the example over here, is going to become 3 is less than 4. If you add 10 over here, you're going to get 12 is less than 13. Whatever you have, sorry, 12 is less than 15. Whatever equation that you have, if you add anything on the same thing on both the sides, you're going to get the same inequality. The inequality symbol will not change. The side which is higher in magnitude will not change, because the change on both the sides is actually equal. So you don't have to worry about this. The inequality would not change and it will still be less than like it was before. So let's move on to the second property. The second property is that of a subtraction property. Now the subtraction property basically states that, just like the previous example, if you have something like a is less than b, and if you subtract both sides from the same number, you're still gonna get the same inequality. Like 2 minus 1 will still be less than 3 minus 1. The thing with this is, no matter how much different numbers you have, if you make the same changes on both sides, just like you made a change in the property a, in that change was an addition change, this change is a subtraction change. So no matter what change that you do in both the cases, the inequality will still hold. This is what these properties are there to tell you. So remember to look at these properties in this way, that no matter what change there is, if the same change is being made on both the sides, the inequality symbol will not change direction. The inequality would still be the same. So either if it is like you're adding on one side and subtracting on the other, for example, if 2 is less than 3 is our inequality, and you add 1 on the left hand side and you minus 2 on the right hand side, the inequality is bound to change, because then it's going to be 3 is less than 1. You can't do that. Your symbol is going to change and 3 will be then greater than 1. But we're not concerning ourselves with that right now. What we are concerned with is the basic properties, to show you what basic properties are. Now we're done with the addition, we're done with the subtraction. Let's go to the multiplication. Now if you have a multiplication, now this one gets a bit tricky, but it's not that much. It's just basic common sense if you just look at it. So if you have an inequality, just like in the previous example, in which a is less than b, and then you have to multiply both sides by c. Now this is where you have to be careful. Now that depends whether c is greater than 0 or it is less than 0, whether c is a positive number or it is a negative number. If c is a positive number, so the same change is going to take place on both sides. Now since both the sides are going to go through the same change, that is being multiplied by a positive real number, that is c, the symbol is not going to change. If you look at the example over here, if 2 is less than 3 and let's just say c is 2, now the first thing that we have to see for this property is whether c is greater than 0 or less than 0. So now we know that the c is greater than 0 because it is 2. It is a positive real integer. So what's going to happen now is you multiply you multiply c on both the sides, you're going to get 4 is less than 6. So this equation will hold and it's not going to change. The symbol is still going to be the left hand side less than the right hand side. Now if the second scenario, if c were to be less than 0, if it was -1, -2 or any number, we're only concerning ourselves with integers right now. So if we multiply it in that way, then it's going to change. Then the value of c is going, then the value of the inequality is going to change. So 2 is less than 3, if it is being multiplied with -2, we're going to have -4 on the right hand side, left hand side, and we're going to have -6 on the right hand side. What this would give us is -4 is greater than -6. If you were to not change the symbol, if you were to keep the symbol as it was before, that is the left hand side is less than the right hand side, you're going to get a wrong answer, because you're going to get -6 is greater than -4. Of course that's not true. So in the multiplication property, what matters is the value of the change that we're making. We're changing on both sides, with the change being multiplication by an integer c, and the value of c, that is basically the magnitude, the either positive c or negative c, that is what matters. And once you figure that out, you will know whether the property is holding or not. Now the same goes for the division property. If you have an inequality with you, that is a is less than b, and if you divide it by c and c being greater than 0, so the inequality will still hold. The inequality will not change sign, not change sides, that is the left hand side will still be less than the right hand side. On the other hand, if c is less than 0, just like in the multiplication property, the inequality sign will change and the left hand side will become greater than the right hand side. Or if it were the other way around, the symbol will change in the other direction. So you see in the example in front of you that if 2 is less than 3 and we divide it by 3, so since we are dividing by a number which is more than 0, which is a positive integer, so the inequality sign would not change. 2 by 3 is still less than 3 by 3. And on the other hand, if the equality sign has to change, it will only change if the value of the change that we're making, that is the division, the change that we're making with the help of any particular integer, in this case the value is going to change because the value is less than 0, and the symbol is going to change because that is the only way in which we can get the correct answer. So these were the properties, pretty simple. Now we come to the solving of the linear inequalities in one variable. So this is what a solution of an inequality looks like. Basically, if we just want to graph it, just like in the number line, when we start learning about real numbers and integers, we use the number line to make sense of everything that we are learning, the new stuff that we are learning. So just like that over here in the inequalities, we're also going to do that. Remember that the solution of a linear inequality in any one variable is actually a real number which makes the inequality true. So that's just like saying that if there is any number, if you have an equation of inequality equation, linear inequality equation in one variable, That means you're going to have that in the form of ax plus b. And if you want to find out the value of x, that will actually be the solution of the inequality. That is going to prove the inequality to be true. Now that is going to be the solution, and that is what we are after in the particular equations that we're going to solve. So if you have a particular example, let's just say x is greater than 6. If you want to plot it over the number line just to make sense of it, so this is 6 over here, and this basically shows the arrow, the arrow in the front of this one is basically shows that x, all the values of x which are greater than 6, that is on this side 7, 8, 9, 10, 11, are going to be the solution to this particular inequality. I just wanted to show you how it is on the number line, just to make one or two things clear on this one. Now the ray over here indicates that the solution set x equals to 6 consists of all numbers greater than 6, right? So one thing that I forgot to write down on the slide over here, when I apologize for that, is the concept of a circle. Now if you were to get this question in an exam, you would most probably have to show whether the answer is x is greater than 6 or x is greater than and equals to 6. That means that whether the value of x is 7, 8, 9, 10, 11, 12, or it is 6, 7, 8, 9, 10, 11, 12. That is either it is only greater than 6 or does it include 6. So now you see, the way to include any number is through the help of a circle. That is a filled up circle. Like this circle is filled up. Now if a circle were to be hollow, we would put it over here in terms of 6. Now I forgot to make that, but if you draw a circle over here, you would basically mean that the answer to this question is x is greater than 6, which would basically mean that the value 6 is not one of the answers to this inequality, and this open circle, that is a circle which is not filled, is going to give you the answer to this. Now in case if you want to include that, like if you have the solution such as this one, x is less than n equal to -1. Now this basically says that all the values of x which are less than -1, that is -2, 3, 4, 5, 6, and also -1. So how are we going to solve that? Is that we basically fill the circle up. That is how we show it on the number line. Of course we draw this arrow over here at a little distance from -1, and this arrow over here basically means that in this direction you have all the solutions, that is in the direction of less than -1. But since we are also including -1 in it, we basically place a circle on top of -1, a filled up circle, a solid circle, so that it shows the -1 is a part of the solution as well. On the other hand, if it were only x is less than -1, we would make an open circle over here, the hollow circle, without it being filled up and without any solid line in between it, without any solid filling in between it. Now let's look at another example. Now you have this equation over here, a very simple equation, which is x minus 2 is greater than 6. So how do we solve this? We basically use the addition property to solve this. How do we solve this? That we add 2 on both the sides. Since we're adding 2 on both the sides, we don't have to worry about what change we are making, either the change is greater than 0 or less than 0, since the only thing that we have to worry about is what property are we going to use. So the property that we are using right now is that we are basically adding 2 on both the sides, and because we are adding 2 on both the sides, the answer that we're going to get is x plus 0 is greater than 8 and x is greater than 8, and we plot it on the number line, and what we get is that this number line in front of you, that all the values greater than 8 are going to be represented in the number line like this. And since we don't have any filling to do over here, because the answer is not x is greater than or equal to 8, it's just x is greater than 8. So we have the answer with you in front of us. Just like the previous example, this is a very simple example. Once again, we have x plus 15, which is less than -7. The way to solve this is that we use the subtraction property for this one. That is x plus 15 minus 15 is less than -7 minus 15. That is what the change we are making on both the sides is -15. So what we are doing with this is that we're going to get another answer, that is x plus 0 is less than -22, and we solve this by the help of the number line. Basically we solve this through solving the equation, but we plot it on the number line. Once again, we don't have to make a solid circle, because the answer is not x is less than or equal to negative 22. The answer is only x is less than negative 22. So this is pretty much it for this lecture. We went through the properties, the really basic properties of the linear inequality equations. We're going to go through some complex stuff. We're going to start with the word problems involving linear equations, and we're going to find out what are the ways of solving that and how to approach those questions. In this lecture we just went through the properties, some very basic questions, how to plot in the number line. If it is just greater than or equal to a particular number, we draw a open circle with our circle which is not filled, which is not solid. On the other hand, if we have to say that it includes that number as well, like greater than or equal to 8 or less than or equal to 8, we draw a solid circle at 8. So we're going to continue with the questions again. We're going to be continuing with the same subtopic, that is of linear inequalities with one variable. And hopefully I'll see you again in the next session as well. Thank you very much.